In this video, we'll consider in more granular detail the impact of the position of the forces acting on the aircraft. We know it's too simplistic to say that the forces will always act through single points on the aircraft. Indeed, before every flight we calculate the centre of gravity position to make sure it's within an acceptable limit. So what effect does this variance in the points through which forces are acting have on us in upset recovery? Starting with the centre of gravity, we know that there is an acceptable band within which we must ensure that we are before we fly. This band and its extent is dictated by both the stability of the aircraft when the centre of gravity is in that position, and also by the control authority that we have to ensure that we can still control the aeroplane with the centre of gravity in that position. Wherever we calculate the centre of gravity to be, we assume that the weight of the aircraft will act through this single point. Equally, we assume that the thrust vector generated by the engines will act from the position of the engines in a forward direction. Depending on where the engines are mounted on the airframe will depend on the moment that this generates. In this case, we have engines mounted slightly above but quite close to the centre of gravity of the aircraft. Therefore, as we apply full power, we may experience a very slight nose down moment, but I wouldn't expect this in this particular example to be particularly marked. However, we may have engines which are mounted a long way from the centre of gravity line of the aeroplane. Perhaps they are on underwing pylons. And in this case, we need to be cognizant of the fact that as we apply full power, we may get quite a marked nose-up pitch. And this could be very significant to us in an upset recovery situation. So think about the aeroplane that you are primarily flying now, and the thrust line of that aircraft, and recall to yourself what happens when you apply full power in your aeroplane. Similarly, the drag line of the aeroplane will act through what we consider to be a single point. Depending on the position of this point, this will have in itself a slight pitching moment. In this case, we have the drag line of the aeroplane slightly below the thrust line and slightly below the centre of gravity. Recall to yourself when you apply speed brakes, or if you have any other aerodynamic braking on the aircraft which significantly increases your drag, what is it that happens to the nose of your aeroplane when you deploy those? The lift vector we assume to act through a point which we call the centre of pressure. This is the resultant of all the little local areas of lift on the wing. In this case, where we have the centre of gravity ahead of the centre of pressure, this is generating a moment which is causing the nose to pitch down. The total moment on the aircraft is equal to the magnitude of the force multiplied by its distance from the centre of gravity. And we're very familiar with this because this is the manner through which we calculate our centre of gravity. In level, unaccelerated flight, the moment generated by the aircraft is zero, and one of the balancing factors which be in play will be a downward or upward force from the tailplane to counter any resulting pitching moment. If your aircraft has a wide range of centre of gravity positions, and perhaps you can change your centre of gravity position during flight through cross-feeding fuel or through moving cargo, then it's potential that your tailplane force will be in a different position depending on the phase of flight that you're in. This will be significant when we come and consider trimming positions of the tailplane and the resulting forces and controllability of the aeroplane. For now, let's leave the balance of forces at this point and not get bogged down into too much detail. Hopefully this has given you a bit of food for thought about the aeroplane that you fly, and it's worth discussing with your crew the impact your aircraft's configuration may have in different upset recovery scenarios.